Good morning, good afternoon, good evening to everyone from wherever you're joining. I'm Gabriel Kwaku Agbeshie from Ghana and a research assistant in the lab of Dr. Kwejo Owusu Ekufu. Unfortunately, he couldn't join us, and I'm doing this presentation on his behalf. About light, light influences our circadian rhythm physiology, behavior, and cognition. While several studies have been conducted in Europe, North America, and some part of Asia, there is a significant gap in our understanding of real-world personal light exposure patterns in Africa, specifically Ghana. Therefore, in this study, we sought to characterize individual light exposure at some parts of the body using the Actilomos device with much focus or emphasis at the eye level. About Ghana, Ghana is situated on the Gulf of Guinea and the Atlantic Ocean in the sub-region of West Africa, with a population of 35 million and majority being youth. So we focus this study in Kumasi, which is located on the south central part of Ghana, and Kumasi is also known as the capital city of the Ashanti region. So in this study, we initially recruited and screened participants for the study and objectively measured the light exposure data using the Actilomos. And then throughout the study period, participants also filled some questionnaires, and we eventually retrieved this light data and visualized and analyzed the data. So on the first day of the study, we instructed participants and introduced them to the study protocol, and we also made them fill questionnaires, the chronotype questionnaire, the morning chronotype, and then the morning, evening questionnaires as well. Throughout the studying period, they also filled out some questionnaires using the MyCap app, and on the last day of the study, they reported to the office where I retrieved the light data from the Axlomos and also made them fill some retrospective questionnaires to assess their sleep environment and light exposure behavior as well. About this study, we recruited 15 participants, where majority were females, about 53.3%, and most of these participants were not employed, but were studying or students at the time. So we went ahead to visualize the light data for these selected participants and found that light exposure mostly happened during the daytime. We also went ahead to visualize the different light exposure patterns for these selected participants and also found that most light exposure happened during the daytime as well. In order to understand the state of photo period, we found that majority of light exposure happened during the daytime as compared to light exposure at night. We went ahead to calculate some light metrics and with much emphasis on the melanopic EDI, and we found that there were some variability or differences in the melanopic EDI, indicating that these selected participants were exposed to different light exposure patterns or were exposed to different light environments, even though they had the same photo period state or similar photo period. We also went ahead to investigate the social jet lag or to better understand the sleep quality of these participants. And we realized that majority of these participants had some kind of misalignment between their biological clock and social clock. And few participants had 0 second social jet lag, indicating that these participants had a better sleep quality as compared to others. In order to understand the light exposure of these selected participants, we compared their light exposure to the healthy light exposure patterns as recommended by Brown et al. And we realized that majority of them were exposed to lights during the daytime which was consistent with the recommendations by Brown et al. And with the evening light exposure, it was also consistent. However, with the sleep time, there were some kind of variability. To better understand the accuracy in light measurements with the act lumos at the different body parts, we found that at the chest level, there was a percentage error of about 0 to 20%, and at the wrist level, about 0 to 70%, indicating that the light measurement at the chest level was more consistent and reliable as compared to the wrist. We also went ahead to visualize the rain cloud plot and found that majority of the metrics were towards the head, indicating that the light measurement at the eye level was also consistent and more reliable as compared to the other body parts. So overall, this study, we found that majority of the light exposure happened during the daytime, and there were some kind of inconsistency of light measurement during sleep where we expected a measurement to fall within 1 lux, but there was some kind of fluctuation at this level of light, at this state of light exposure. In this study, we encountered some challenges where participants were confused with the bedtime and sleep time, or the AM and PM, and this called for data manipulation before the data analysis. For some participants, the ax lumos was also off on the last day of the light study, affecting a complete result. Some participants also encountered internet challenges, which affected their inputs for the ecological momentary assessment questionnaire. In this study, the act lumos was limited in spectral properties, and then the self-report measures of sleep behavior also introduced some kind of recall bias. The study involved mostly students, which also limited the diversity of the study participants. In future, we hope to improve the wearable sensor, which is the ACT Lumos, with higher spectral power distributions, and also integrates physiological markers such as the melatonin test to better understand the effect of light on cognition. In conclusion, this study investigated the light exposure patterns at the different level of the body part with much focus at the eye level. And we also visualize the light data of these participants in Ghana. The light exposure during the daytime met recommended light levels by Brown et al. However, some variability in light levels during the evening and sleep time occurred. In our subsequent analysis, we hope to explore the behavioral factors and chronotypes and how they relate to this change in personal light exposure. We would also like to acknowledge Ramet, and then Toom and Melidos for bringing up this interesting project. And much thank you and gratitude to our research team at KNUST as well for making this project successful. And a very big thank you to Professor Manuel and Dr. Kwejosu Ekufu as principal investigators on this project. And I'm very grateful for working under their supervision. Thank you.